This is factoring polynomials when it's the difference of two squares. I want to start off with these two examples. When we see x squared minus 9, what we actually see is x being squared minus 3 being squared. When you have that kind of situation, what you actually have automatically is this one minus this one and this one plus this one. Well, where's the plus come from when it was subtracting? Well, watch what happens here when I multiply x minus 3 and x plus 3. X times x gives me x squared. X times 3 gives me plus 3x. Now I'm going to do the FOIL with this one. Negative 3 times x is minus 3x. Negative times 3 is negative 9. These two terms, plus 3x minus 3x makes 0, so we're left with x squared minus 9. When it's the same but with two different signs, they will cancel out for the middle term, so you get a perfect square from here and a perfect square from here, but with it being negative. So it would be minus the perfect square if you separate it like that. That's any time you have perfect squares. Here it is in algebraic notation. We have an a minus a b, and they're both squared. This is not a minus b being squared, because then it would be a minus b times a minus b, and with the same negative, same sign, you'd end up with a middle term. They would not cancel out. So this is something we don't want to consider. Instead, what we have whenever you have it two perfect squares being subtracted, you have an a minus b and an a plus b. Or the b could be here and the minus could be there. It wouldn't matter as long as one is plus and one is minus. So you would have a times a, and you would have plus ab, and you would have minus ab, because when you multiply it doesn't matter which letter comes first. And then here we have negative b squared, and these would cancel out, so you'd have a squared minus b squared. So that's the concept, that you will cancel out the middle terms, which means if you recognize what this is and you see they're both perfect squares, you can just immediately go to a minus b and a plus b. So let's practice a couple of these. Okay, if I give you, let me write practice. I'm going to give you two of them, and I want you to do them yourself. So first one will be x squared minus 25, and the second one will be x squared minus 121. Go ahead and do them yourself. Stop the video and then come back to it. In 5 seconds I'll show the answer on the video. You can pause it and then come back to it and see my answer. Okay, what we have here is 5 squared. That means that's x times x and 5 times 5, so I can say x plus 5 and x minus 5. Or x minus 5 and x plus 5, doesn't matter. This one is 11 squared, so I have an x that's being squared and an 11 being squared. So it's going to be x minus 11 and x plus 11. That's all it is to that. Now let's look at a more complicated, a slightly more complicated one. On this one now, what you see is perfect squares, but here we have a double perfect square. This is actually 3 squared x squared. And of course we have minus 5 squared. You should see this and think that instead of squaring these separately, that you should do it as 3 and x together being squared. Don't do this, do this. Because if you now do that, what you have is here's your a and here's your b. So when you set these up, with one of them being minus and one being plus, you know these are 5s, but what goes in here is this whole 3 and x together. So that when you multiply these two, you get 3x times 3x, 3 times 3 is the 9, and x times x is the x squared. And then 5 times 5 is the 25, and negative and plus makes it negative. If you multiply it all the way out, you're going to get a 5 times 3 is 15x, minus 15x, so the middle term cancels out. At this point, it's just pure recognition. That's 3x, both being squared at the same time, and a 5 squared. Over here now, that's the same thing. You need to recognize that that is a square of an 11, That's the square of an x. Here you have 12 and y. This is a quick reminder that you should know your perfect squares. In fact, we'll go over that in just a moment here. Now, let's see. We just put that into 11x plus 12y and 11x minus 12y. Plus 1 minus the other. Notice this one had a variable with it. So what? It doesn't matter. I threw that at you, and if you recognize what's going on here, it's not an issue because that's 12 squared and y squared. You can put them together as a square, and then that's your b. This is a and this is b. A plus b and a minus b. Now, notice so far I have done, let's see, 3 squared, 5 squared, 11 squared, and 12 squared. And there's other squares you'll be getting, including a couple that are practiced in just a moment. But what that means is that you really should know your perfect squares. So I'm going to put a couple of practice problems in a moment. But first, on the side over here, now 1 squared is 1, 2 squared is 4, 3 squared is 9. I want you to continue and please write them down all the way to 12 squared. See if you can remember them. Okay, pause the video and come back to it. I'll write them all out in a moment, but I want you to try it from memory first and see how many you can get. Alright, now I'm going to show the rest of them. That's 2 squared, that's 3 squared, that's 4 squared, that's 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared. You should have these memorized perfectly, completely, without even thinking about them. You should actually know all your multiplication tables all the way up to 12 times 12 without any hesitation whatsoever. The faster and better you are at your multiplication tables, the easier everything in math is. Yes, you can use calculators. Very simply, they're a lot slower than somebody who has their numbers memorized. I can use the calculator. I use it for all the bigger numbers. I don't use them for the smaller numbers. That's one reason I'm pretty fast with most of my problems, is because I just know my numbers. The better you know your numbers, the easier and faster that everything in math gets. If you don't know them, you can muddle through, but everything's a lot slower. And you don't recognize the combinations of numbers nearly so easily, and you'll often make more mistakes. So I highly recommend that you have these memorized perfectly. If you don't now, practice them, work on them. Here are 2 practice problems. Okay, I'm going to give you 49x minus 1, x squared, 49x squared minus 1. And I'm going to give you 100x squared minus 9y squared. Okay, pause the video and take a few moments to go ahead and figure these out. Start the video, unpause it when you are done. I will start talking in 5 seconds video time. Okay, here I am. I can see that that's 7 and x together that are squared minus 1 that's squared. I purposely put this one here to let people recognize that a 1 is actually the result of 1 times 1, so we can use it as a perfect square, just like I showed here as 1 times 1. So now if that's 7x squared minus 1, it's 7x minus 1, and it's 7x plus 1. Voila! That's the answer for this one. Immediately, just 1's minus 1 plus. On the one, same concept. Okay, that's going to be 10 and x that's being squared minus 3 and y that's being squared. So I can do 10x minus 3y, and I can do 10x plus 3y. Whoops. Okay, now we're going to take a look at a new thing. That was all the difference of 2 squares. Now what we're going to look at is going to be perfect squares. Okay, I'm going to talk about that. Okay, so now here, this is a different special case. X squared plus 10x plus 25. Here, we don't have a subtracting. What we do have is we have a perfect square here and a perfect square here. This is actually the result of adding up those squares there. So when you think of this, this is 5 squared. One way of think about it is that this middle term is the result of taking this common factor, the 1 that's being squared, and that 5, multiplying them and doubling them. So I'm going to think of it, I'm going to write this up this way as a thought. Ax squared plus, not that yet, this is b squared. So the b and the a, what this is actually 2abx. So that number will be twice these two multiplied together. So instead of 25, this is 5 squared. So 1 times 5 is 5, double it and you get 10. So that means all we really need to do is take x and it's plus this 5 and it's squared. See, when you have the perfect squares here and the middle number is the result of the a and the b, or the a, it's actually a and c, when these are multiplied together, well, no, I'm going to keep it as b because we're going to say of it this way. This is a and b. When we do x plus 5 times x plus 5, x times x is x squared. This is plus 5x. This is plus 5x. This is plus 25. So we have x squared plus 10x plus 25. So when you have the exact same thing being multiplied out, the middle number is the result of the coefficient times the c, a and b, multiply, actually with the x. You multiply these together. 5 times 1x is 5x, and then you double it to get 10x. So if this is a perfect square, and that's a perfect square, put them together in the same thing, and see if when you square it, if you actually get that number. Let's try that with this one here. Right. This is actually 8 squared, or think of it as 8x squared is the right way to think of it, and this one's 7 squared. So what I'm going to do is I'm going to do 8x plus, this is a plus, so therefore it's 8x plus 7, and I'm going to square it. That should be the answer. I'm going to put it in a dashed line first. Now I'm going to multiply it out and see if it really is. 8x plus 7 and 8x plus 7. 8 times 8, there's the 64x squared. 8 times 7 is 56x. 7 times 8 is 56x. And then plus 49. These two together make 112x, and there we have it. 64x squared plus 112x plus 49. That's the original problem. Now, you can verify by seeing, like in this one, if you do the 1 and the 5, 1x times 5 is 5x, and double it, you get 10x. Here, 8x times 7 is 56x, double it, you get 112x. I actually find it easier just to put these together and then multiply it. It both checks if I'm right, and it verifies that this one's the right number. Okay, now, a couple of ones to practice. Okay. So, I'm going to draw a line here. I want you to practice these two. 81x squared minus 18x plus 1, and 121x squared minus 88x plus 16. So you're looking for a perfect square and a perfect square, a perfect square and a perfect square. Go ahead and do those. Pause the video. Come back to it when you're ready, and in about 5 seconds I'll start talking and on the video time, and go through the answers. Okay, so what we have here is a 9 and an x being squared and a 1 being squared. So I can do 9x plus 1 squared. Now, that should be the answer for it immediately. I'm going to, now I see a minus. This was a plus I put here. I think it's supposed to be a minus. I'm going to leave it as a plus and see what works. 9x plus 1, because if I were to make the mistake and not think about it, I'd be wrong. If I check it, I should find out then that I'm wrong, or right. 81x, squared. 9x times 1, that's plus 9x. This is plus 9x. This is 1 times 1 is plus 1. So I get 81x squared plus 18x plus 1. This, though, was a minus. So if I had just made that a minus instead, I would have made that minus and that minus. It still would have then given me a positive 1 over here, but it would have made this a negative 18. So the correct answer is actually 9x minus 1. Now I caught myself pretty fast here because I could immediately think about that. But if you didn't catch it, you wouldn't have realized it unless you checked it and multiplied it out. If you do that, it's easy to go back and see, oh, I should have put a negative in there. So whatever sign that is here, that's the sign that goes in with it. Okay, this one will have the same thing. It'll have a negative. So I have an 11x that's being squared and a 4 that's being squared. So it should be 11x, whoops, minus, it's whatever the sign is of the middle one. So that should be the answer. Now let's go ahead and check it. 11x minus 4 and 11x minus 4. So this times this is 121x. This one is negative 44x. Aha, that's half of the 88 rather. This is another negative 44x. We can see it will be negative 88. And then negative 4 times negative 4 is the positive 16. So that means that this is actually our answer, because we can see that'll make the negative 88x from the beginning one. So recognize that when you have a trinomial and the first and the last numbers are perfect squares, it's probably going to be a square of a binomial. So you can immediately put them together with that sign, multiply it out, and see if this is what you get. Right? That's one way to handle these. You can also just do it the same way we did the other ones, and if you had done that, the ones where I would multiply this times that number, and then I would and all the factors of that to add up to negative 88, the one that does, and then put them into the x's. You know what? I'm going to get a pretty big number here. Oh boy, what's that going to be? 1,000 something, I'm not even sure, with a whole lot of factors. I think this is a much easier way to see it. So when you get something that's really big, huge numbers, probably it's going to be something where you should do the simpler method. Okay, so in this section there were two main concepts. One of them was the difference of two squares, how to factor that so that you get an A, so you get an A plus B and an A minus B set up. And when you have perfect squares, when the A and the C are actually perfect squares, it's most likely going to be a square of a binomial like that.